The system itself was barely holding together, a lopsided tangle of thunderstorms with no clear center, but the warning that went out because of it stretched from the Florida Panhandle all the way to Louisiana, starting the moment the National Hurricane Center upgraded a drifting tropical depression in the northern Gulf into what would become Tropical Storm Bertha, the second named storm of the season. And that first advisory was just the opening scene. Over the following 10 days, the storm crawled erratically toward the coast, closed beaches from Pensacola to Biloxi, made a rare July landfall in southern Louisiana, and then dragged its flooding rain hundreds of miles inland before finally dissolving over Texas. By the time we're done here, you'll understand exactly what forecasters warned about, what actually happened on the ground, and what it tells us about the rest of this hurricane season. Today, we are going to break down exactly what is going on, where it is most dangerous, and whether things could get even worse. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now. Have you ever personally ridden out a tropical storm or hurricane along the Gulf Coast? Tell me where you were and what it felt like. If you want to be the first to know every time something major happens, subscribe. It is completely free. A thumbs up also helps enormously. Let us go for 5,000 likes on this one, so the algorithm actually shows it to people who need to see it. Now, let us get into it. Let's start at the beginning, because the way this system formed says a lot about why Gulf storms can be so difficult to forecast precisely. In mid-July, a tropical depression was drifting erratically in the northern Gulf of Mexico, centered roughly 110 miles south of Panama City, Florida, with sustained winds of just 35 miles an hour. The National Hurricane Center's early advisories noted meaningful uncertainty in both the storm's exact track and its eventual strength, a genuine forecasting challenge, since a slow-moving, poorly organized system like this one is buffeted more by small shifts in the surrounding atmosphere than a strong, well-organized hurricane would be. Within roughly a day, the system strengthened into Tropical Storm Bertha, prompting the National Hurricane Center to issue a tropical storm warning stretching from coastal Alabama through Mississippi and into eastern Louisiana, meaning tropical storm conditions, sustained winds of at least 39 miles an hour, were expected within the following 36 hours across that entire stretch of coastline. Here is why that warning mattered even for a storm that never grew into a hurricane. Bertha's winds topped out at 45 miles an hour at landfall, well below hurricane strength, but the storm's wind field was unusually broad and lopsided, meaning tropical storm force winds extended as much as 160 miles from the center, far wider than a compact, well-organized system of the same intensity would typically produce. To put that in context, that means communities hundreds of miles from Bertha's actual center still experience genuine tropical storm conditions, rough surf, beach closures, and localized flooding, well before and after the storm's center made its closest approach. Let's talk about what actually happened when Bertha came ashore, because the storm's track through the following days is the clearest real-world example of how a Gulf system can defy simple prediction. Bertha made landfall in St. Bernard Parish, Louisiana, roughly 40 miles east of New Orleans, on a Wednesday afternoon, an unusual location and timing that meteorologists noted made it just the 10th tropical cyclone to make a July landfall in Louisiana since reliable records began in 1850, and the first named storm to strike the state since Hurricane Francine in September of 2024. Southern Louisiana was, at the same time, under both a tropical storm warning and an extreme heat warning simultaneously, a combination the National Weather Service said had not occurred in that region in at least 2 decades, based on records dating back to 2005, underscoring just how unusual the overall weather pattern behind this event actually was. Now let's talk about storm surge and rainfall specifically, since that is where the real, measurable danger from a weak but broad tropical storm like Bertha tends to concentrate. Forecasters had warned of storm surge up to roughly 3 to 4 feet along portions of the Louisiana and Mississippi coastlines, and up to 5 or 6 inches of rain in some areas, enough to trigger localized flash flooding, especially in urban, poorly drained neighborhoods. Scientists generally do not conclude that a tropical storm's wind speed alone determines its danger, and Bertha is a clean illustration of why its wind and surge were the primary hazard for the Deep South states directly in its path, while its moisture, carried far beyond the storm's actual center, went on to help fuel a separate, more serious flash flooding event hundreds of miles away across southeast Virginia, parts of the Carolinas, and northern Georgia, a stalled front interacting with tropical moisture producing dangerous rainfall totals well outside the original warning area. Here is a detail that matters for understanding cumulative risk in this region specifically. Bertha's rain fell on parts of coastal Mississippi that were, at the time, still recovering from flooding caused by an earlier system, Tropical Storm Arthur, which had struck the southeast in June. That changed fast the calculus for emergency managers in the affected counties, since already saturated ground and still damaged infrastructure meant a second, even weaker system carried outsized risk of compounding the earlier damage rather than being treated as an independent, isolated event. If you follow hurricane season news at all, this pattern of one moderate system stressing infrastructure that another system then compounds probably already rings a bell, since it is one of the more consistent and underappreciated dynamics of an active Gulf hurricane season, distinct from any single storm's individual strength. To put a number on the broader season context, this year's Atlantic season has been running in a period researchers have already tied to a warm phase Atlantic multidecadal oscillation, a natural ocean cycle associated with more frequent and more intense hurricane activity across the basin, meaning storms like Bertha are occurring against a backdrop of generally elevated seasonal risk rather than in isolation. Let's talk about what happened as Bertha continued westward, because the storm's gradual weakening illustrates a genuinely useful forecasting principle. As Bertha crawled across southern Louisiana and toward the upper Texas coast over the following 2 days, it steadily lost strength, its already poorly organized structure unable to hold together against unfavorable upper-level winds, the same kind of wind shear that limits a storm's ability to intensify. By the time it reached the outskirts of Houston, the National Hurricane Center discontinued all remaining tropical storm watches and warnings, and Bertha ultimately degenerated into a remnant trough rather than sustaining tropical characteristics all the way to dissipation, a relatively unremarkable end for a storm that, at its broadest extent, had put beaches under warning across 4 states. Keep an eye on the rest of this hurricane season, too, because Bertha is unlikely to be the last system to test the same stretch of coastline before the season ends. Forecasters have specifically noted that near-record warm Gulf water temperatures fueled Bertha despite the storm's disorganized structure, and that same warm water remains available to any future system that manages to organize more efficiently. Scientists cannot accurately predict the exact number or strength of storms still to come this season from any single event, but the underlying ocean conditions that made Bertha possible have not changed, and remain a genuine, ongoing factor emergency managers along the Gulf Coast are factoring into their planning for the remainder of the season. The difference between a community that weathers a storm like Bertha with minimal disruption and one that faces compounding damage is not luck. It is whether beach closures, evacuation guidance, and flood preparedness are taken seriously, even for a storm that never reaches hurricane strength, and whether communities already damaged by an earlier system have had time and resources to recover before the next one arrives. Local officials across the affected parishes and counties closed parks, piers, and low-lying roads well ahead of Bertha's arrival, a proactive step credited with limiting storm-related injuries despite the widespread beach and coastal impacts across such a broad stretch of coastline. So what happens next? The Gulf Coast moves back into a monitoring posture, watching the tropics for the next system to develop while continuing cleanup and recovery from Bertha's flooding and coastal impacts. Despite dramatic online headlines suggesting a far more catastrophic outcome was narrowly avoided, there is currently no scientific evidence that Bertha represented anything beyond what it actually was, a genuinely disruptive, wide-reaching tropical storm that produced real flooding and coastal impacts without ever reaching hurricane intensity, exactly the kind of storm meteorologists say deserves to be taken seriously without needing exaggeration. Let's go deeper on why forecasters described Bertha as a genuinely difficult storm to pin down, since that detail matters for understanding what a tropical storm warning actually communicates versus what people sometimes assume it guarantees. A tropical storm warning means forecasters have high confidence that tropical storm force winds, sustained winds of at least 39 miles an hour, will occur somewhere within the warned area within a defined window, generally 36 hours. It does not mean every location within that warning will experience the storm's most severe conditions, nor does it lock in a precise landfall point days in advance, particularly for a slow-moving, poorly organized system like Bertha, whose exact track shifted meaningfully in the day before landfall as forecasters incorporated new reconnaissance aircraft data. Hurricane Hunter flights, which fly directly into developing systems to measure wind, speed, and central pressure, were specifically credited with confirming Bertha's upgrade to tropical storm strength, the kind of direct measurement that satellite data alone cannot fully replace. It's also worth understanding the extreme heat component of this story, since it rarely gets attention alongside the wind and flooding hazards but genuinely compounded the danger on the ground. With southern Louisiana under simultaneous tropical storm and extreme heat warnings, residents faced a specific, unusual combination. Dangerous outdoor conditions from heat and humidity, even as they prepared storm shutters and evacuation supplies, followed by the loss of air conditioning for many households once tropical storm force winds began knocking out power. Emergency management officials specifically flagged this combination as raising the risk of heat-related illness during storm preparation and cleanup, a hazard easy to overlook next to the more visually dramatic wind and flood coverage. Now let's talk about the East Coast flooding connection, since it's a useful example of how a single storm's impacts rarely stay contained to its warning area. Bertha's tropical moisture, pulled north and east by the broader atmospheric pattern, fed directly into a separate, stalled frontal system producing serious flash flooding across southeast Virginia, the Carolinas, and northern Georgia, hundreds of miles from where Bertha's center ever tracked. Meteorologists were explicit that this was a distinct, secondary hazard tied to the same storm system, illustrating why emergency planning increasingly has to account for a storm's moisture plume and downstream effects, not just its direct wind and surge path. This is also a moment worth using as a genuine prompt rather than a scare. If you live anywhere along the Gulf Coast, this is a reasonable point to check your household's hurricane season readiness now before the next system forms, rather than scrambling once a new advisory is issued. None of that requires panic. It requires the kind of preparation that matters most in the exact stretch of the calendar. An active, warm phase hurricane season makes it statistically more likely to be tested again. We'll continue tracking this story as the season develops, and if the National Hurricane Center issues advisories on the next system, we will bring you the details as soon as they are confirmed, not before. Let us go. See you in the next one.